Hello students, welcome to my channel, and today my topic is optics and I will discuss about it in many parts. Let's start the video. Now let's start the topic reflection. So first of all we have to know what is reflection. Let's draw a picture. This is medium 1, this is medium 2. A wave coming from medium 1 approaches the surface joining medium 1 and medium 2, and a part of it come back in this medium. The whole incidence is called reflection, and the surface joining the surface from where the wave reflected back is called the reflector. Now let's come about reflector. There are many types of reflector. Maybe there are plane reflector, maybe there are spherical reflector, but we are interested in spherical reflector. This is a part of a sphere. If this part of the sphere acts as the reflector, then this is concave reflector, and if this part of the sphere acts as reflector, then this is convex reflector. We have drawn a part of a spherical sphere, and this is a spherical curvature. In this spherical curvature, the middle point of the spherical curvature is here. It is the pole of the spherical curvature, and we will term it as P. And ये जो spherical curvature है, ये जिस स्फीयर का अंश है, जिस स्फीयर का अंश है, इस स्फीयर का जो सेंटर है, this called as the center of curvature of this spherical curvature, and the radius of the sphere is called as the radius of curvature, यानी कि ये. And the line joining the pole and the center of the sphere, यानी कि center of curvature, is termed as principal axis. Let's talk about the laws of reflection. What is the first law of reflection? And this is the incident wave, the reflected wave, and the perpendicular drawn in the incident point of this incident wave will live in same plane. And what is the second law of reflection? This is the angle of incidence and the angle of reflection will be same. We will discuss about the focus of the concave mirror. Yeah, this is concave surface, and this is the principal axis. This is the pole. Let's rays come from infinite and incident here. So as per the law of reflection, if we draw a tangent to the surface, then this will be a perpendicular, and the incident angle and the reflected angle will be same, and it will be reflected in this way. Yeah. Similarly here, this is the perpendicular to the tangent, and the incident angle will be same as the reflected angle, and the wave will be gone here. So all of the parallel wave coming parallel to the principal axis where meet after reflection is called the focus of the concave mirror, and we will term as F. And this is the pole, and the difference between the pole and the focus is called the focal length of the concave mirror. Let's talk about the focus of the convex mirror. Let's waves coming from infinite parallel with the principal axis incident here. Let's draw a tangent here. This is the perpendicular to the tangent, and according to the second law of reflection, the wave will be reflected back here. Similarly here, this is the perpendicular and the wave will be reflected back in this way. Okay. Now look at this point. This point, we after reflecting back to the surface, it will be assumed that the reflected waves are coming from this point. The reflected waves is coming from this point, and this point is named as the focus of the convex mirror, and the distance between the pole and the focus is called the focal length. Now, let's come as in the different cases of reflection in concave mirror as well as the convex mirror. Now, what will be happen if the wave coming parallel with the principal axis incident on the convex or concave mirror? This is a concave mirror. This is the principal axis. Sorry. This is the principal axis. This is the pole. Now, if waves coming parallel with the principal axis, and this is the focus of the mirror, and this is the center of curvature of the mirror. It will go back in this way, यानी कि फोकस से ये रिफ्लेक्टेड वेव बैक करेंगी. मैंने ये आपको पहले डिस्कस किया है कॉनकेव मिरर के बारे में, जो जब हम फोकस के बारे में डिस्कस कर रहे थे तब मैंने ये बोला था आपको. एंड कॉन्वेक्स के बारे में भी सेम ही है. अगर कॉन्वेक्स में भी ये पैरेलल आए गिरेंगे, सो it will be assumed that they are coming from the focus. Let's talk about the second case. If waves coming through the focus and incident here, let's draw a tangent here. This is the perpendicular and the incident angle will be same as the reflected angle. It will be back here, यानी कि पैरेलल जाएगा प्रिंसिपल एक्सिस के साथ. We'll talk about the convex. This is convex. Sorry. This is convex mirror. This is the focus, and this is the center of the curvature. If the wave incident here as assumed as it is coming out from focus, then draw a tangent here. It will be the perpendicular to the tangent, and this will be the reflected wave. So let's talk the third case. If the wave coming in the direction to in between the center of curvature, यानी कि सेंटर ऑफ कर्वेचर के अंदर से अगर ये वेव आया तो क्या होगा? Let's draw a tangent here. This is the tangent and this is the perpendicular here. So ये perpendicular के साथ 0 डिग्री एंगल से इंसिडेंट हुआ है. So as per the second law of reflection, it will be come back in the 0 degree angle with the perpendicular. So which wave is incident here, it will be reflected back in this direction. Okay. Now here talk about if a wave incident here, यानी कि it is assumed that the wave is coming out from this center of curvature. इस direction में अगर ये incident हो, then this will be the tangent here and this will be the perpendicular here. In this case also the incidence angle is 0 degree, so the reflection angle will be 0 degree. So here the wave come back in this way. We will discuss about what will be happen about the image of a object which is located at the infinite from the concave mirror. This is focus and this is the radius center of curvature, and we know all that the waves coming from infinite are parallel, so they are parallel to the principal axis. Now as we know when the waves are parallel to the principal axis, they passes through the focus. So here the image will be formed at focus. Image will be formed and the image will be very small compared to object. Yeah. Now comes to the second topic. Object is placed outside the center of curvature and this is the pole. Whatever. Now the ray coming from A will be incident here, and as it is parallel to the principal axis, so it will go through the focus. Okay, and when it is go through the center of the curvature, as we have learned earlier, they will reflect it back in this way. So here in this cross-sectional area, the image of A, which we named as A dash, will be formed, and the ray from B will be incident here, and as this is perpendicular to the surface, it will be reflected back along that direction. So here will be the image of B, that will be B dashed. Will be the characteristics of this image, that is, it is in between the center of curvature and the focus, and this is small in size, and this is opposite in the direction of the object. Come to the third case. Here the object is in between the center of the curvature and focus of the curvature. This is named A and this is B. The wave parallel to the principal axis will go in through the focus. Now the wave going to here, which is in the line joining C to this surface, will reflected back in that way, as this is parallel to that surface. Okay, now this will be the image. Okay, this is A dashed and this is B dashed. This is the image. Clearly you can see that the image is bigger than the object and it has formed outside the center of curvature, and this is opposite in the direction 1. Now the object is placed in the focus, so the wave going parallel with the principal axis will go in this direction, and the wave coming the line joining the curvature, center of curvature and the curvature will reflected back in this way and go will there. So they are parallel in nature. These two waves are parallel in nature, so it can be assumed that the image will be formed at infinite from the concave mirror. Let's begin the fifth case. This is the concave mirror and the object is now situated between the focus. Parallel ray, and they will go back to the focus, and the line joining center of curvature and the surface, it will go there and then perpendicularly reflect back and will be go in this direction. If you notice that these two waves are diverging, so they cannot be meet anymore. So what we have to do? We have to extend these waves in backward direction. Where they meet, they will form an image. Now this is the image of AB. You can already notice that this image is bigger than AB, and this is an unreal image because they are extended versions of these waves. In previous cases, we have seen that the waves are actually meeting at a point. So those were real images, but this is an unreal image. Let's come to the convex mirror. We have discussed already about the concave mirror in each cases of the image formation. Now at the first case of the convex mirror is when the object is situated at infinity. So we have already noticed that if the objects are situated at infinity, this is the focus of this convex mirror and this is the center of curvature. Now when the object is situated at infinity, they always send waves parallel with the principal axis. Now they will be reflected back in that way. Okay, and if we extend these waves, we can see that it will be assumed that the waves are diverging from that point focus. So the image will be formed at focus and it will be very small about than the object. Let's come to the second one. Now the object is placed outside the pole, not at the infinity, from the convex mirror. So the wave parallel to the principal axis will be come back in this direction. Okay, and the wave coming at that direction will be go back perpendicularly here. So these waves are also diverging in nature, so they cannot be meet at infinity. So what we have to do? In their extended version, we will have an image of AB, A dashed and B dashed. So this image is also an unreal image and it is smaller than the object and it has formed between the focus. Students, if you like this video, enjoy this video, so please like the video, share with your friends and comment in this comment box, and we will be come back soon with part 2. So please stay tuned with us and subscribe to my channel.